Good evening, everybody. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum, welcoming you to tonight's edition of Night Skies at Home. Night Skies at Home is our home edition of our popular Franklin Institute Observatory program called Night Skies at the Observatory. But since we're all at home on quarantine, here we are in my backyard, right at home at the Pitts Observatory, if you will, underneath a really lovely night sky. Great evening sky tonight. Nice spring evening. Temperatures are really nice. Fortunately tonight, the wind speeds are low, so hopefully you can hear me really well. And tonight, what we're going to have the opportunity to do is to find out what's the great stuff to see in the evening sky at this time of this year. We're going to look at one constellation in particular. We're going to look at the constellation Gemini. And we picked that constellation because it's way over on the western sky right now. And we have just this last little window of viewing time, just another week or two or three before it disappears below the horizon for the season. And we won't get to see it again until late next fall. So we have this opportunity to catch up with that one. And Gemini is an interesting one because it has two bright stars that are easy to recognize and a star pattern that's easy to recognize. So I thought we'd start with that constellation for our constellation of the week, of the evening. And then what we're going to do is we're going to take off and get prepared for next week's historic launch of two astronauts from Cape Canaveral in Florida. For the first time in 9 years since 2011, we're going to be launching astronauts right from American soil, from an American spaceport. It's been a little while since we've done that because when the space shuttle program ended, our launch capability here evaporated. And we've been working with our partners, the Russians, to provide launch services to take us up to International Space Station. But because the American space program is taking new steps going forward in solar system exploration, we have launch vehicles that need testing. We have new capsules that are going to be tested, and there's going to be a big test next week. And we want to prepare you for that. There's all kinds of great stuff that you can catch up with to understand what's happening. And you really should, because this is a new big step in our space exploration program. And I want you to be all up to speed on what's going on with that. At the same time, we're also going to take your questions. Let's not forget your questions. They're really important. We want to make sure you have an opportunity to ask all the questions you like. And so we're going to start out with taking some of your questions if we have any. And then later on in the program, we'll make sure to come back to your questions repeatedly, time after time after time, so that we can get an understanding of what it is you're interested in and answer your questions. You know, along with the constellation Gemini, I'm going to ask you a question about a constellation. Now, Gemini is a particular constellation because it's one of a group of 12 very special constellations. I can imagine that many of you might know 12 constellations. If you don't, you know one at least anyway. You know your astrological birth sign. You know that constellation, don't you? Well, Gemini happens to be one of the 12 astrological birth sign constellations. But they actually belong to a group with a different name. And that group that they belong to begins with the letter Z. And I'll bet you know what that Z word is. I'll tell you what, if you think you know what that Z word is, why don't you send us a quick text and let us know what you think that Z word is, that group of 12 constellations that Gemini belongs to. And at the same time, why don't you also send us your astrological birth constellation as well, okay? We'll see if we can get these two to match up well. They will go well together, okay? So there's a little bit of an astronomical challenge for you to give us some information tonight about your connection to astronomy. We all have one. I bet you know what yours is, okay? I know what mine is. I'm not sure I know all the other ones. Maybe you'll help me figure them out, but I know what mine is. Okay, so we have a lot to do this evening, and we're going to get started with a lot of what's available for us to see in the evening sky this week. Let's start right off with our regular weekly report on phenomenon. What's the sky phenomenon for right now? This is the general portion in which we talk about sunrise and sunset and things like that. So let's get started right now. So for right now, this week, sunrise is now coming at 5:39 a.m. Wow, eye-poppingly early, right? Well, it's going to continue to get earlier as we head toward the summer solstice coming up about a month away from this night tonight. Today's the 21st of May, so we have another 4 weeks left before we get to the summer solstice, right? What we call the first day of summer. Well, it's at that point when we will actually stop gaining minutes of sunrise time in the morning, sun rising earlier and earlier. And we also reach the maximum of our evening sunset times, all right? So that's 1 month from now. So right now, sunrise is at 5:39 a.m. We're picking up about 1 minute and 35 seconds every day of extra light. That's going to be decreasing as we head towards June 21st. And sunset now is at 8:16 p.m. That's getting pretty late, but we still have another, let me see, I think it's 20 minutes of time left to add to the evening. So that means that sunset for us, the latest sunset, is going to be around 8:35 p.m. So we still have a ways to go. But you know what? Let me give you a little hint about this. This is a really gorgeous time of the year to be out in the evening. The air is still cool. There are not a lot of bugs out. The evenings last long into the evening, sun setting by 8:35. And so this is a really wonderful time to sort of like languish and absorb the extra number of minutes and hours of sunlight that we have during the course of the year. If you don't pay attention to this, what happens is it's fleeting, the time is fleeting, and that sort of marker of when we come to that point goes right by us, and we sort of miss it. And the next thing we realize is that, days are getting shorter already. So let's not jump ahead of the season, but just keep that in mind that you should go out and observe that. Okay, so guess what? New moon today. So if you're looking for the moon in the evening sky, you won't find it because, as it just so happens, in this portion of the moon's cycle around the Earth, in its phases, the moon is in the sky at the same time as the sun and actually quite close to the sun. So it's not going to cover the sun as in an eclipse, but it's right along the same sort of angle in the sky, if you will, either just below the sun or just above the sun. And so what this means is that the moon rises almost as the sun, the moon is rising the same time as the sun is rising and setting the same time as the sun is setting. So now tomorrow what's going to happen is the moon's going to rise about 45 minutes later. And what that's going to do is push the moon a little bit behind the sun. And so maybe not tomorrow, but Saturday evening, if we have clear skies, over on the western side of the sky after sunset, maybe about an hour or so, you should be able to see a very thin crescent moon down close to the horizon. And this is your opportunity to begin marking the days of the lunar cycle. Best to remember them in 7-day increments, like weeks. So as it turns out, you can watch the moon go from its new phase to first quarter phase in 7 days. And then 7 days later, it will come to full moon. 7 days after that, last quarter, and 7 days later, it comes to back to new moon again when it's made the complete cycle. So let's see, we did 7 days over 4 weeks. That's 28 days. The full lunar cycle is 29 and a half days. So that's pretty close, in being able to divide it up in a way to remember it, one phase per week. So that's an easy way to do that, okay? That's also where we get the word month from. That whole lunar cycle, we used to call that a moonth, but it became shortened over time from moonth to month. So you can see there's a direct connection between the cycles of planets and objects in the night sky and the calendars that we have here on Earth. So that's how we get the word month. In any case, that's what you can do with the moon right now. Saturday evening, look for that thin crescent right after sunset. So what's great to see in the evening sky these days, over in the west after sunset, Venus is getting down close to the horizon just after the sun sets. So we're going to lose that from visibility pretty soon. I hope you enjoyed viewing it through late winter and into spring. It was really glorious. We'll have an opportunity to catch it again around in the later portion of the year as it will become visible in the morning sky this fall. So we'll get back to that, but I hope you enjoyed seeing Venus. If you're up early in the morning, well, guess what? Jupiter, Saturn, and Mars are still there. What's actually happening is that Jupiter and Saturn seem to be sliding across the south, heading toward the west, while Mars seems to be heading back around to the northeast, kind of. But it's just a difference in the motion in the orbital speeds of these planets. Mars is coming along with Earth, and so as that happens, Jupiter and Saturn are being left where they are. And so Mars and Earth, we're rushing ahead of them, heading around the sun. And So eventually, those planets will back into the evening sky, and that's where we'll catch them this summer. So by July, mid-July, we'll be able to see those planets in the evening sky. So hold on till then if you don't like to get up early in the morning. Okay? Now there's a comet that's available in the pre-dawn sky also. That's Comet Swan. Comet Swan is a comet that's passing through the constellation Perseus right now. So if you can identify the constellation Perseus using a star map or using the Stellarium app that we've been using on computer, you are able to find that constellation. It's over on the eastern side of the sky in the morning before sunrise. So if you're out there at 4:30, that's a perfect time for you to try to catch Comet Swan. It's not as bright as we would love a spectacular comet to be, but at least you can get an idea of what one looks like. Fuzzy object in the sky with a tail that stretches out behind it. It doesn't move quickly, but it does move a little bit every day. So your best bet is to use a pair of binoculars to try to spot it. Not necessarily a telescope. A telescope is good and everything, but you'll be much better off with a pair of binoculars. You can get yourself to a place where you have clear skies. And you know what? This is the perfect opportunity for those folks that live at the Jersey Shore. Yes, indeed. If you live down at the shore, you can go out in the morning before sunrise, look out over the ocean, and you'll have a great opportunity to look for not only those bright planets in the morning, but to look for Comet Swan as well. So give that a shot and see how that turns out. And let me know next week if you could see it. I'd love to know. Where I am, you know, it's going to be too low on the horizon for me. I'll have to head down the shore too to see it. But let me know if you see it if you're living down the shore. Okay, great. So up next, International Space Station. We'll talk a little bit more about other things with International Space Station later. But guess what? International Space Station does have evening flyover views. In fact, there's a low International Space Station pass tonight. Yes, tonight, like right after this program. 8:55 p.m. over in the northwestern sky. Now, for me, where I am, northwestern is right over here behind me, and it's going to pass across through the northern sky over into the northeastern sky where it disappears. Now, it's not going to be very high off the horizon, about 25 degrees above the horizon, but you'll be able to see it as long as you have a clear view out to the northwest, to the north, and into the northeast. It's a nice long pass all the way across the sky, so you have plenty of opportunity. I think it'll be up for 5 to 6 minutes, so you have a great chance to see that. Remember that app we've been talking about the last couple of weeks, See a Satellite Tonight? Well, try that app. We have a link for you to go to use it so that you can find out where it will be visible in your neighborhood, and then you'll be able to see it without too much difficulty at all. There are a bunch of other ones coming up, space station flyovers. Not as high, but you can use that as an opportunity to try and figure out how to see International Space Station. We'll talk a little bit more about that in a second. Okay, let's check and see if we have any questions. If we have any questions, we'll answer some questions right now, and we'll get to your questions. So what do we have?
Could you talk a little bit about SpaceX's Starlink satellites and their passing ISS?
Okay. So the question is about the SpaceX Starlink satellite system. And I think the question is asking you, does it cause any problems for International Space Station as these objects fly past each other in Earth orbit overhead? So let's talk about the Starlink system first. Starlink happens to be a satellite communication system that has been created and put into orbit by the SpaceX Corporation. And what SpaceX is trying to do is to provide low-cost, wideband internet, easily accessible internet, I should say it this way, internet access at low cost for places all over the world. So the idea is by putting these satellites in orbit, people will be able to access the internet via these satellites at a much lower cost than having to build the infrastructure in so many countries around the world. Now, that's a great idea. The problem is, though, there are so many of them that are going to be put into orbit. Literally thousands of them will be put into orbit. Now, they're not very big. They're actually quite small. But just the same, there's some concern about having so many of these objects in space. Some people think that this is tantamount to having a gang of extra space junk, if you will, because it's just adding to the number of objects in orbit around the Earth. And that's true, but there is a service that should be provided by these satellites. Now, question is there any danger to International Space Station? No, because these objects orbit at different altitudes, and so that won't really be a problem. There's no need to worry about that. But you should be a little bit concerned about the number of satellites in this system that are being put aloft. If you just Google Starlink, you can find out a lot more information about these satellites. It's not the first time that there's been a system like that put up, but this is an interesting one that you should take a look at to learn more about. What's the next question?
Is it possible to view the Milky Way with the naked eye?
Next question is it possible to view the Milky Way with the naked eye? And guess what? You've been outside looking at the sky at night. Anytime you look up at the night sky, you're actually looking at the Milky Way. And that's because the Milky Way is the entire galaxy in which our star is found. So any stars you see in the night sky, those stars are all part of the Milky Way. Now, okay, I know what you're talking about. You're wondering about being able to see the arms of the galaxy as they stretch overhead. So when you ask that question, people are really asking, can we see that band of stars across the sky? It's sort of like a hazy glow of stars across the sky that we often call the Milky Way. Yeah, that's true. We can see that under clear, dark skies. Now, in a center city environment, in any urban environment, any city environment, your chances of seeing it are a bit lower because there's so much extra street light, night lights around. So what you have to do is get yourself out someplace where the sky is darker. Any increment you can go out gives you darker skies. The farther out you go away from city lights, the darker the sky is, the easier it is to see the Milky Way. Here's a hint. You can do that right now because, of course, under this quarantine, you could go out to some place where you'd have plenty of separation between you and anybody else, out someplace where the sky is nice and dark. You can take a pair of binoculars, and as you find the Milky Way, you can sort of sweep through the Milky Way with binoculars, and you'll see all kinds of great stuff. You don't need to know exactly what it is, although you could take a map of the Milky Way with you if you wanted. But you know what? It's such a wonderful feeling to enjoy the connection with the night sky that you get when you go out and look, and binoculars help to enhance that, and the Milky Way really looks great under binoculars. So try that. What's the next question?
There was a very bright sunset yesterday. What made the colors so bright?
Ah, yeah, very bright sunset. Yeah, it was beautiful, wasn't it? And that was a situation where if you didn't see it last night, the sky was a beautiful red color. And so that red color that we are seeing is caused by light from the sun filtering through particles of the atmosphere. And what happens is we throw out all the other colors of the spectrum, and just the red is sort of transmitted through to us, and it makes the sky look red. It throws red light up onto the clouds. So there's a saying that goes with that helps people better understand weather conditions, if you will. And that saying goes like this. It's something that mariners used to use hundreds of years ago. Red sky at night, sailor's delight. So last night there was a red sky, and the indication of this is that, or what comes from this meteorologically, is that if you have this kind of weather condition where you have red skies in the 12 to 24 hours ahead of the next day, well, that means that there could be a high pressure system building into the area that will help give good weather. That's what we have today. The other side of that saying is red skies at night, sailors delight. Red skies at morning, sailors take warning. So in this case, we had the red skies at night, sailors delight. Great weather today. I hope you enjoyed it. One more question, then we'll jump off into some of our specifics.
How is space trash cleaned up, and does it affect space telescopes?
Hey, there's a great question. The question is, how does space trash, say it again one more time?
Yeah. How is space trash cleaned up?
Yes.
And does it affect space telescopes?
How is space trash cleaned up, and how does it affect space telescope? Well, I'm sorry to say, we're not cleaning it up. Yeah, we've in some ways turned our Earth orbital region into a big trash dump of leftover parts of rockets and satellites and things like that. You know, for 99% of the space program here on Earth, we haven't really been concerned about leaving pieces of junk left over in space, like old rocket boosters and old satellites, defunct satellites that are no longer being used. There was no provision included in the design to intentionally bring them down out of orbit after their useful life. Now, certainly, many satellites have had orbital decay in which they've come back down through the atmosphere on their own and burned up or fallen into the Earth's oceans. There's been plenty of that. But there's still a tremendous amount of material up there in orbit that is defunct, not useful, not being used, no longer being used for any reason at all, and non-functional. And we have no way to get it down. So I think in the future, I think there's a business opportunity here. Somebody could design a system to go up and collect that stuff and do something with it, okay? Recycle it, maybe. That's not a bad idea. So there's a possibility of what can happen with that. Does it affect Space Telescope? Fortunately, they call it space for a reason. There's a lot of room up there, a lot of room up there. And we also keep very close tabs on what's orbiting where. There are designated altitudes for different kinds of satellites, and they are assigned to stay in those orbital altitudes so that there isn't any conflict with other orbital altitudes. Thank goodness there hasn't been much in the collision, there haven't been many collisions like this, but they can be devastating. We don't want that to happen. Space Telescope hasn't had a problem at all. International Space Station, no problem at all. There could be an issue, but there hasn't been. And actually, there is an active way to sort of redirect satellites in case it seems like two are getting close to each other. So that's another really interesting topic that you can dig into onto the web, find out what happens to space junk. Okay, so we'll take more of your questions in just a little bit, but there's a tremendous amount of really cool stuff that's happening in the next week. And I want you to be really aware of what's going on with that so that you'll be up to speed on that. What I'm talking about is that next week, there's going to be a historic space flight taking place next Wednesday, May 27th, and the launch takes place at 4:33 p.m. in the afternoon. This is a wonderful time because it means everybody can watch, and you need to be watching this particular launch. And the reason why is because I said it's historic, and it's historic for like three really interesting reasons. The first reason is there hasn't been a manned launch, a crewed launch from the United States since 2011. So let's think about that for a second. Since 2011, any kids under 10 years old, hey, you out there watching this program, are you under 10 years old? Well, there hasn't been a manned launch from the United States in your entire lifetime. So for you, under 10 years old, and those of you that feel like you're under 10 years old, this is going to be really exciting because we're going to do a launch right from Cape Canaveral, Florida at Kennedy Space Center. And it's going to be the first time, as I said, in 9 years that this has happened, okay? It's our return to launching people from the United States into space. And that's a really big step because it's going to restart the United States' capability of reaching low Earth orbit. So that's one reason. Two astronauts going up. We'll talk about them in just a moment. Now, what's the next part? The next piece is, this is actually a demonstration mission, a test flight of a very special piece of equipment. It is the SpaceX Dragon crew capsule. Now, SpaceX has launched plenty of boosters before, and they've been incredibly successful with that, and that's a very good thing. But the crew cabin, that's called the Dragon crew cabin or crew module, that's only been launched once before, and it was unmanned. That was a very successful launch, but because we didn't have people inside, we didn't prove that it's safe for humans to travel in this. Now, everything on that first flight went just great. Everybody's satisfied with how things worked out. But this time, we have to actually do it with crew on board, okay? And that's what's going to happen beginning next Wednesday, May 27th at 4:33 p.m. in the afternoon. You're going to be able to watch the launch live and follow it as it ascends from the launch pad all the way up into space. You'll be able to follow it online without any difficulty at all. Now, the astronauts that are going on board this mission, they're going to actually spend time at International Space Station because that's the destination of this particular mission. It's a mission to take two astronauts up to International Space Station. And so they're going to arrive the very next day, Thursday, May 28th, and they're going to spend some time there. They'll spend a few months. Now, we don't know how long they're going to spend there. It hasn't been announced yet how much time they'll spend there, but they'll be there for a few months at least. And what they're going to do while they're there is participate in all the other activities and experiments that are being done on board by the astronauts that are there. And then those two astronauts will bring that spacecraft back when they will be able to test the reentry and the recovery of that spacecraft after it lands back here on Earth. So this is going to be a historic mission all the way around. The astronauts that are going up on this are two veteran astronauts from the Space Shuttle program. Doug Hurley and Bob Behnken are the two astronauts that are going to go on this flight. They've been training for this for years. They have plenty of experience under their belt. They're perfect for this opportunity. And this is a revolutionary spacecraft. So let's get into this a little bit deeper because I want to show you some of this so that you really understand how this works out. I'm going to ask my producer to hand me the laptop here so that we can go off and take off. There we go. Thank you. I'm going to come right up here. Let me just make sure I've got all my cables connected here and everybody's still good. All right, here we go. All right. Now, so folks, here's what's going to happen. I'm going to share my screen with you. And as I share my screen with you, I'm going to take you out to see some of the really cool stuff that's coming up with this. There we go. Let me just get this properly positioned. Okay, and a little bit like that. How's that? Okay, good. My production team here is helping me get everything configured properly, so you're not looking up my nose too much or any of those kinds of things. Okay, let's go. Let's share the screen. Okay, I'm going to go right out to here, and I'm going to say share. And we're right out here. Hopefully you can see, I've got some junk here on my screen, but that's all right. Don't worry about that. Okay, so let's get started. So the first thing we're going to do is we're going to take a look at the SpaceX Demo 2 mission profile. Let's start there. So I know it's a YouTube video. We've provided the link for this YouTube video. I'm going to make this full screen so we can all see it. And hopefully you can watch along here. Maybe you even hear some of the audio of this in the background. And so what we can see here now is the SpaceX launch vehicle. This is the Falcon 9 launch vehicle. And this vehicle has the capability to take payloads up to low Earth orbit and has been doing so successfully for a number of years now. In fact, the one thing that really makes this rocket system stand out is that it has the capability of returning to its original launch site automatically so that the rocket booster can be reused. Here we can see in this video simulation, we have two astronauts making their way out to the capsule. And in the simulation, you see them on board now. And this is what the Dragon capsule looks like. Now, the Dragon capsule is going to have the capability to take many more than two astronauts, but for this first flight, just two astronauts will make the trip. Okay, again, this is a test flight. It's a demonstration flight. And after this flight is completed successfully, this means that the SpaceX launch system, the booster, and the Dragon capsule will be available to be used on a regular basis by American astronauts reaching International Space Station. We'll no longer be dependent on the Russians to give us access to Earth orbit as we had been before. Now, this is really a great boon because as we were using the Russians to get us to International Space Station, it cost us $70 million for each one of those launches. So what's going to happen is that the Dragon spacecraft is going to make its way to International Space Station, and it's going to dock at the space station. And you can see here how the nose opens up so that the docking mechanism can connect with the port at International Space Station. And once that docking occurs, then what will happen, of course, is the spacecraft will stay connected to International Space Station. The astronauts will stay on board for several months, and then they'll return to Earth in the same capsule. Now, the view that you see here, of course, is really high speed and it's running really fast, but it takes us up to that point where they demate or deconnect, and the spacecraft is being configured to return to Earth for reentry and recovery and the return of those astronauts. International Space Station flies at an altitude of 225 miles up, 17,500 miles an hour. And as the two spacecraft are trying to come together, they're both going at that rate of speed, but the way of maneuvering to get them close together takes extreme dexterity if it's being done manually. In this case, the entire flight will be done automatically so that everything will run according to plan. As the spacecraft returns to Earth, it'll come back down, and of course, it'll be recovered after reentry. And this is a reusable spacecraft, so that it will be able to be reused over and over and over again. Now, the intention, of course, is to land this right on board a recovery craft in the ocean so that it can be brought back for reuse. Okay, so let's jump out of this. That's good. I really like that one. That's a lot of fun. We're going to skip that right now. And what I'd like to show you next is there's this really, really cool app that SpaceX has provided. And this app is a simulator of the manual control system for docking the Dragon capsule at International Space Station. And you too can fly this thing. So let's go over and take a look at that, okay? So here it is right here. Here's the SpaceX docking program. Let me see, I'm gonna bring this up into full screen for us here. There we go. Okay. Yes, blah, 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 blah. Here's some instructions. Blah, 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 blah. Okay, let's go. We'll just get into this and get started so you can see what it looks like. And then you can download this yourself or access it yourself. We're providing the link for you so you can get to it on your own, and then you can maneuver the spacecraft. Okay, so what all do we have here? Here's what we have going on here. Right here in the middle of the screen is the view out the front of the spacecraft. And the intention is for you to use the controls over here on the right side and over here on the left side to maneuver the spacecraft right over to this diamond right here. Right in the center, you see that green diamond, that solid green diamond? That's the actual docking clamping mechanism right there. And what you want to do is you want to put this crosshair target here right on top of this, and you need to use these controls to do it. Now, as I said, what's going to happen actually is that this mission is going to do the docking automatically, completely computer controlled. So using the radar systems of both spacecraft to line everything up and make the docking connection. But if the astronauts had to do it by hand, these are what their manual controls actually look like. So this isn't just like a play simulator. This is really what they see if they were actually controlling it manually. So now you can get a feel for doing that. Okay, so what do you have to do this? All right, well, let me reduce this a little bit more here so I have some more room. So we have two sets of controls here. And these controls allow us to move the spacecraft in different ways. So if you hover over the button, it'll tell you what it does. So this one is for pitching up and pitching down. And this one is for doing what's called yaw, which is rotating left and right like this. So this is a yaw motion. This is a pitch motion, okay? And as you click these, what happens is you get an incremental movement in that direction. So what I'm going to do is I'm going to demonstrate what yaw looks like by yawing left, by rotating to the left like this. So I'm going to press on this, and you can see there was a little curve there that shows you what the yaw looks like. Now you can see the motion picking up. Now, right down here at the bottom of the screen, here's the yaw measurement. And you can see how much yaw there is. See how much I'm moving to the left? Now, I can make that go faster. But you know, in space, it's very important to be very careful in your incremental movement. You have to do it incrementally. You don't want to overshoot a target because that means you're using up more fuel than you really ought to be using. So I'm going to slow it down a little bit. And then what I'm going to do is I'm going to, let me just explain this one over here. So on this side, we have something called translate up, translate down, translate right, and translate left. Now, translate means we're going to move the whole spacecraft over, not just move the nose left to right or up and down. We're going to move the whole spacecraft. That's what translation means, okay? So now I can still see that my yaw is moving in this direction. So I'm going to try to stop that motion, bring that down as low as I can. And you can see down here, my rate per second is 0.0. So now I stop that. So what I'm going to do is I'm going to translate up. Just to show you how this works, I'm going to translate up, and I'm going to give it quite a bit of translate motion, and we're going to see how we are actually moving the spacecraft up toward that. Okay, here we go. It's coming up. Okay, see how it's coming? Slowly, I'm trying to be careful. I could make it go faster just for the sake of time, but I don't want to crash, okay? So, and we're not going to go through the whole thing because I want you to do this at home. This is exactly what the astronauts would do if they had to dock manually. They would do this exact same thing. So let's just look at the picture here. Here you can see the Earth in the background. See here's some ocean here, some continent here. You can see this in the background here, right? Okay, here's International Space Station up here. Here's some solar panels here, some solar panels out over here. Here's some modules along here. Here's the axis, the backbone right across here. Okay, again, here's our docking port right here. That's where we're trying to get to. So we're translating upwards so we can get in that direction. We've got a horizon ball up here in the top corner over on this side. And then we also have these other commands down here that allow us to roll the spacecraft. And that means we're going to just roll it over like a barrel in one direction or the other direction. And then over here, we have our translate speeds. And this is translating forward, which means heading towards space station, or translating backwards, which is moving away from space station. So as you can see, just a second, I'm caught on something here. There we go. We have all these controls that let us maneuver the spacecraft. And you can see what change has been made right here. We've come right down to here. I'm going to jack up the speed here. Let's see if we can really get it moving here. There we go. We're coming right up. There we go. So you can see how this works. And then I can point it in different directions. Let's see. I'm just going to give it a little bit of roll just so you can see what the roll is like. Let's see. I'll give it a little bit of roll this way. Now you can see what that roll looks like. See what I've done? And you can see just at the top here how much roll we have going on here. See the rate there? Okay, you can see the measure in degrees of roll, and you can see the rate at which the roll is happening. Okay, so you can see where all these controls are. So here's where your roll is. Here's where your pitch measurement is. Here's your yaw measurement, and here's your XYZ axis motion measurement here. Here's your range down here that shows you how far away you are, and here's the rate at which you're either closing or spreading apart. You can see now space station is rotating around there. We got too much roll, so I'm going to back this down a little bit and get my roll down to 0. And you can see I've rolled 39 degrees and my rate is now down to 0. And you can see now that I've got a really weird thing going on here. I've got to figure out what I did with that. I have to figure out which rate that is. That's my z-axis rate there, and I have to correct that so I don't keep going in the right direction. Uh-oh, I know what I did wrong. Oh boy. I've got myself going in the wrong direction here now, don't I? Ooh, man. I can see it starting to take off. Hey, you know what? We're going to get out of here because I don't know what's going to happen here. So let's just get out of this one and we'll go back to the next step so that we can see what's happening here. Okay, so there's that one. That's a lot of fun too, okay? Now, as I mentioned, so I hope you'll try that and build up your own skills at maneuvering the spacecraft to get into dock at space station. If you start now, maybe you can do it real time for the docking maneuver coming up next Thursday evening on the 28th. Okay, so who knows where the spacecraft is going to end up? We'll find out. So the reason why SpaceX is the company that's actually doing this is because NASA has a partnership with SpaceX, and the partnership gives SpaceX a contract actually to build launch capability, and that's building the rockets and building the capsule as well. And there's a very good reason why SpaceX has been chosen for this. I mentioned a little bit earlier that SpaceX, the reason why SpaceX is so popular, why it's come into prominence these days, is because it has the ability to reuse its rocket boosters. It can actually refurbish, refill them, and reuse them again. And that puts them head and shoulders above all of the other space agencies around the world because they're doing something that no other space agency can do right now, and that's reuse their rocket boosters. And that's important because in reusing your rocket boosters, guess what happens? You can now drive the cost of access to space. You can drive that down dramatically because the more you reuse the booster, the cheaper it is to operate it. So now it costs a lot less. And everybody wants to have a less expensive system to operate, especially if it's a system that is reliable and works well. And that's what's happened with the SpaceX program, is that their system works really well. Now, here's a video I'd love to show you that demonstrates exactly what their capability is. So this is a mission that took place a couple of years ago when a Falcon Heavy launch vehicle that you see right here in the upper corner had a flight up to test how it could land. So here is the core booster. Now in the Falcon Heavy, it would be the center booster plus a booster on the right and a booster on the left. So here's the core booster coming down. But look at these views down here. These are the views of the side boosters as they're coming back down to their landing spot where they took off from. So that dot right there, there's their target, one there and one there, two separate cameras. What you see now is just the core booster firing, and now watch right up here as they come down to land. It's the most exciting thing ever. Tandem landing of two rocket boosters. Look at that. Isn't that amazing? You can hear the crowd in the background cheering at SpaceX. So this is the very first time that two rocket boosters together in tandem simultaneously landed very close to where they took off from. That's an amazing thing. And this is what gives SpaceX the jump on all of the other space companies and all of the other space agencies around the world. So this is what you're going to be looking out for when you watch the launch next Wednesday. Is you want to see that rocket booster come back and land where it took off from. Okay, so now the last thing about SpaceX, or another thing about SpaceX that's really important, is where they're going in the future. Now, you know, the space program heading into the future has a major target out there, and the major target that everybody knows about is potentially sending astronauts to Mars. Now, that's a big trip, and it's a very complicated trip, and we are nowhere near ready to do that yet. In fact, what we have to do to get ready is we have to prepare, and the way that we're going to prepare is by first building up the launch capability, the rocket capability, the spacecraft capability, and the human capability to be able to spend that much time in space. You know, if we wanted to go to Mars right now, the shortest trip we could make, the absolute shortest trip we could make is about 18 months, round trip. That's the shortest we can do it. 6 months out, about a year back, with only a little bit of time on the surface of Mars, like a week or so, right? Well, that's not a good way to do that because you spend 6 months in space getting there. That's how far away Mars is. You can only spend a week on the surface before you have to launch to come back to Earth. And the reason why is because Earth and Mars are sliding past each other as Earth orbits faster than Mars. So we did the launch when the two were closest to each other. Well, actually, we aimed for where Mars was going to be, and we sent the spacecraft out to there. And we arrived when the two planets were at their shortest distance from each other. But during the time of the travel, 6 months later, the Earth went much farther ahead of Mars. So they're no longer close together for a return trip. So we have to wait for Earth to come back around again before we can make it across that shortest distance between the 2 points. Well, that's going to be a long trip and an arduous trip, and we've never done anything that long before. Remember, Scott Kelly, just 2 years ago, spent 340 days in space. That's more time than anybody else has spent at any one time, 340 days. Well, that's not even a year. So you can see we have a lot to do. So what's SpaceX going to help us do? SpaceX is going to build a launch system that will allow us to take everything we need to go practice at the moon before we go on to Mars. And this is what we have to do. Take it step by step by step, leaving Earth, making our way to the moon, developing our capabilities on the moon over long periods of time before we're ready to make the next big step up to Mars. And as you can see on the screen right now, here's the next thing that's coming for SpaceX: service to Earth orbit, the moon, Mars, and beyond. And they want to use something that they call Starship. And this is what Starship looks like. Let's get a closer look. Here's what their Starship vehicle looks like. This is a really big rocket. The height of this rocket is 160 feet, and it has a launch capability that can carry so much more than any other rocket could carry in the past. And that's really important because we want to be able to carry as much equipment and supplies as we can on a trip out to the moon and even on out to Mars. So this spacecraft, called Starship, is a spacecraft that is thought that should be able to do that. It looks as if its payload capacity is something like more than 100 tons of material can be carried into space. More than 100 tons. That's an amazing amount. No spacecraft that we've had in the past has ever been able to carry that much cargo or people. So this is actually under construction right now for test flying. And pretty soon we'll see some of the first test flights of this spacecraft. Let's get a quick look at some animation of what that launch might look like for this spacecraft. This comes to us from SpaceX. Again, it looks very much like the one did previously, but this is a much, much bigger rocket, bigger than anything we've ever launched from Earth before. But the idea, again, is to be able to carry a lot of payload, a lot of supplies and equipment into Earth orbit. Now, if we didn't do it this way, we'd have to send a lot of rockets. And this is the method that was used by NASA to build International Space Station. The space shuttle, which had enough cargo space that you could fit like a school bus in it in the cargo hatch, well, that was big for the time. But we had to do a whole lot of launches in order to get enough material up into space to build International Space Station, and it took years to do it. So the beauty of this system is not only does the spacecraft Starship have the capability to carry 100 metric tons or 100 tons, we can also reuse the booster rocket over and over again, driving down the cost. So these are the reasons why this is going to be a very, very special and historic mission for us to see, because SpaceX is building this capability, and it's going to be a very exciting future. And this is what we can keep track of to see how everything's going to work out as this program heads off into space. So we provided the links for all of these videos that you've seen here this evening, so you can go watch them in their totality, and you can enjoy them, and you can watch them over and over and over again, and you'll get a feel for what's happening in space. Okay, so don't forget, next Wednesday, May 27th, 4:33 p.m., you'll be able to watch the launch live. It'll be spectacular. And we've also provided links for where you can go to get more information about this. If you want to watch the launch, nasa.gov will be carrying this. And of course, you can go to SpaceX's website as well and watch it there. And you'll be able to keep track of the entire mission if you like to do that too. So stay tuned for that. We'll talk more about this. In fact, next week when we come back, we'll find out whether or not it was a success. And maybe we'll have some images from International Space Station of the docking that's actually happening next Thursday. Boy, wouldn't it be great if it happened during our program and we could actually watch it? Well, we'll see how that goes. We don't know the exact time yet, but by this time, next Thursday, they should be docked, and we'll find out what happened then. Okay, great. Let's see if we have any other questions at the moment before we jump off into our last stuff for the evening.
We do. Max would like to know, what is Hamius ring made of, and do astronomers really know? Hamius, H-A-M-E-A-S? I don't know.
Oh, I'm not sure I quite understand that question.
Well, why is the science of weather called meteorology?
Yes, why is the science of weather called meteorology? Well, it's called meteorology because it has to do with stuff in the sky, really. That's the real reason why it has that name, because it has to do with stuff that we see in the sky. So we talk about it as meteorology. And it seems strange because meteors actually are from space. So you would think there might be a different name for meteorology rather than this term that we use for weather, because the weather is not from space, but meteors are from space. So yeah. So what's up next?
The Webb telescope. Do you have an update?
Oh yes, James Webb Space Telescope. That's a great question. Everybody knows about Hubble Space Telescope. It's been a great telescope, 30 years in service, providing all sorts of really wonderful images. And the next space telescope of any great size that's going to be launched will be James Webb Space Telescope. James Webb will be 6 times larger than Hubble Space Telescope. And instead of being at an altitude of 420 miles above the Earth's surface, James Webb Space Telescope is going to be parked at a location 1 million miles out. It's going to be parked in a location where it has great access to the night sky, and it will be able to detect all sorts of really wonderful things and great new information that will help us understand more about the formation of the universe, more about the possibility of extrasolar planets, maybe even find planets like Earth way out in space somewhere, all kinds of really great stuff. There's a catch though, and the catch though is that it will not be serviceable. Hubble Space Telescope, we could send repair crews to fix things that went wrong with Hubble Space Telescope. We can't do that with James Webb Space Telescope, unfortunately, so it has to work properly. Now, what's the update? Well, the update is it is now all completed and all configured, ready for launch, okay? So, and it's even been delivered for launch, but it's not going to be launched until next March. So we have another year before it gets integrated, as it gets integrated into the launch vehicle. And then hopefully, keep our fingers crossed, it will launch next March 2021. So keep your fingers crossed for that, and we'll watch that too. What's next?
When will Jupiter and Saturn be closest together?
Oh, when will Jupiter and Saturn be closest together? Well, it's a question of closest together in what way? Do you mean as we see them in the evening sky? If so, that's going to happen this summer, and you'll see them at their closest approach for the summer. And that's coming up in this summer, July. I think it's going to be late July that'll happen. You'll be able to see it, though, in the evening sky. So we'll talk about that as we get closer to it. It's great to see that. But you have to remember, though, when we see them close together, that's just how it appears to us optically. There's actually a huge gulf of distance between the two. So for example, Jupiter is 484 million miles away from Earth. Saturn is 885 million miles away from Earth. So there's 400 million miles of space between the two planets. So they don't really come close to each other. They just appear to be close to each other as we see them in the sky. What's next?
All right. How does being in space affect the human body?
Oh, there's a really fine question. How does being in space affect the human body? You know, humans aren't really built to be in space. We are not built to actually live and work in space. As we do this at International Space Station, we're the ones who are creating an environment for us to live in that's as close to Earth as we can get in space. But you know what? While we might be able to make the temperature proper and the air, provide oxygen and provide air pressure and all those sorts of things, there's one thing that we can't get away from, and that's the effect of gravity. And that's one thing that affects humans tremendously. Oh, there's one other thing, by the way, radiation. We can't forget that. So gravity affects us by reducing the amount of pull on our bodies. So our bodies don't have the resistance of one Earth gravity to work against to keep our muscles fit and toned. And that's also true for our heart. So what happens is our muscles lose, our body loses muscle tone, our bones start to lose the capability to create red blood cells. And this, of course, can cause all kinds of problems. I really recommend you read Scott Kelly's book after his return from 340 days in space to get a really intimate view of how living in space affects us. So while he had a really great environment, the lack of gravity really took a toll on him. And here's one thing I'll tell you about that I thought was really amazing. He said, and he came to visit the Franklin Institute. I got to meet him and talk to him and all this kind of cool stuff. Well, one of the things he said was, when he came back to Earth, having clothing right next to his skin made his skin feel like it was on fire. And that's because being in a low gravity environment, clothing would not naturally just lie on his skin. So his nerves in his skin got used to not having anything touching them. So when he came back to Earth again with something lying right on his skin, he said his skin felt like it was on fire. Really, really interesting. The other thing I have to mention is radiation. Space has horribly deadly radiation, and we have to do everything we can to protect astronauts on board spacecraft, on the surface of other planets. All of these things are detrimental to us, as well as how many other things. It's just not the right environment for us, although as explorers, we do the best we can to protect humans from being in space. We'll do one more question before we look at the constellation for the evening.
All right, Jacob wants to know, how are meteorites created?
Hey, Jacob, that's a really great question. How are meteorites created? How are meteors created?
Meteors, yes.
How are meteors created? Yeah, thank you, Jacob. Well, you know, meteors are really hunks of rock, hunks of space rock. And there are lots of hunks of space rock in our solar system. And there's so much of this stuff left over from the beginning of the solar system. Now, when the solar system first began, not all of the dust and dirt and trash and detritus left over from the beginning of our star got swept up into planets. So we find that there are huge fields of junk left over from the beginning of the solar system. We know these fields as belts. And in fact, there's an asteroid belt between the orbit of Mars and Jupiter that has a lot of this junk in it. And there are plenty of other asteroids orbiting around our solar system. And these all represent stuff that either was a planet and then broke up, or never became a planet. And so it's remained out there orbiting around the sun. So occasionally what happens is a gravitational tug from one of the planets or another will pull some of this material in toward the center portion of the solar system. And we'll see these objects in the evening sky as meteors across the sky. And then the other stuff that makes up meteorites is the dust and dirt that's trapped in the nucleus of a comet that melts out as the nucleus of the comet comes close to the sun. The gases melt out, the dust comes out into the tail behind the nucleus, and that can fall into the Earth's atmosphere and cause that too. Okay, so let's go look at the constellation for the evening. To do that, we're going to go over to our fun program here called Stellarium Webb. Here we are now out underneath the night sky, and things are darkening nicely here. We're looking out toward the north, and what we'd like to do is look out toward the west. So I'm going to rotate our sky around this way. We can see that the time here in our Stellarium program is actually 9:35 in the evening. So we're about an hour away from that right now. So as the sky darkens, you'll be able to see this out there. And I'm going to point out these two stars, this constellation that I want you to know right over here. It's the constellation Gemini. And Gemini is a constellation that refers to two twins from Roman mythology. Here are the two twins right here, and you might not be able to see it, but I'm going to draw it out for you. Here are their heads. Here's Pollux, and here's Castor. That's the name of these stars right here, Pollux and Castor. And these are the heads of the twins. And if you look down through the stars, you can see these long lines of stars that represent their bodies. So here are their heads, and here are their feet right here. Foot down here and foot down here. Now, let's bring the constellation art. Well, let's do this first. Let's do the outline. And here you can see what they look like. Here are the heads, here are the arms, the bodies, and the feet. And let's look at the artwork. And here's the artwork of the Gemini twins right here, Pollux and Castor. Now, I chose this particular constellation because these two stars are easy to see. Pollux here is 34 light years away from Earth. It's a single, cooler, yellow-orange giant star, and it's the closest giant star to Earth, just 35 light years away. So as you look out and see it over in the west there, it's just 34 light years away. It's the closest giant star to Earth. Pollux has a planet actually orbiting it, and it's about twice the mass of our planet Jupiter. So this star, closest orange giant to Earth, has a planet about twice the size of Jupiter orbiting it, and it takes about 600 days for the planet to orbit that star. Now over here, Castor is 52 light years away from Earth, and it's 12 times brighter than our sun, and it has a surface temperature of 17,500 degrees Fahrenheit. It's also a double star, and it has a companion. That star has a companion that's about 8.5 million miles away from the main star, and it takes it about 400 years to orbit the parent star. So as you're looking out, you can see this information about the star. So here's the other thing I asked you earlier, if you knew what your astrological sign is, if your astrological birth constellation is. Well, Gemini is one of those. Cancer is another of those astrological birth constellations, as is Leo, as is, we're going to come around to the south here and just bring us down to Virgo and Libra. And one that's rising over here in the southeastern portion of the sky, Scorpius. Okay, so you might know it as Scorpio. So between Scorpius, Libra, Virgo, Leo, Cancer, and Gemini, you have 6 of the 12 constellations that are known as astrological birth signs. Did you figure out what the name of this 12 constellation group is? The name begins with a Z. Did anybody guess what it is?
Yes.
Oh, somebody did. If you guessed zodiac, that's correct. These constellations represent the zodiac band that encircles the entire sky. We're seeing 6 of those zodiac constellations when we look from Scorpius over in the far east, over to Gemini in the far west. And those 6 are, as I said, are just half of that band. The other half of the band is in the sky during the day and won't be visible until this winter, okay? So these 12, though, are significant for a very particular reason. And that reason is not that these are astrological birth signs. It is that these 12 constellations, in their circle, mark the path of the sun, moon, and planets across the sky. So this is where you'll find the planets in the evening sky. you'll find that the sun, the moon, and the planets all travel through that band. And that's what makes this band of constellations important and worth knowing. As it just so happens, because the sun may appear in one of those constellations the month you are born, that's how you identify your astrological birth sign. Where was the sun? In which zodiac constellation was the sun on the day you were born? For me, the sun was in the constellation Aquarius. You can figure out what time of year I was born if you just figure out when the sun is in Aquarius. And you can figure out the same for your own birth sign as well. So that's our constellation for this week. It's the constellation Gemini, the Gemini twins. Here it is right here. And if you just look over toward the west, where you'll see Venus down close to the horizon right now, the Gemini twin stars at the heads right here, Pollux and Castor, stand out because they're nice and bright, and you'll be able to identify them and the rest of the body as well. Okay, one more thing we have to do for this evening, and that is just take a look right over here for where we might be able to see satellites in the evening sky, particularly International Space Station. Now, next week, International Space Station is going to be visible in our evening skies as the Dragon capsule is docking with it. So let's look at what's available tonight. Okay, so let's look right now. We have at 8:55 p.m. International Space Station is going to be flying overhead, so we'll be able to see that. And if you use this particular program, it will show you where in your neighborhood you'll be able to see it. Now, there are two objects that are visible. One is a Russian rocket booster, and the other is International Space Station. Now, the Russian rocket booster itself is not going to be very bright, so I'm not going to recommend you try to see that unless you live someplace where the sky is clear and dark. But International Space Station, yes, you'll be able to see that without any difficulty at all. Now, let me see if I can, here it is right here as it shows up, zipping across the northwestern sky around to the north, as I mentioned before, rising up back over here in the northwest, going across the northern sky and setting over in the northeast. So you can look for that tonight. Tonight's a clear night. You should be able to see it. And if you use this program, we've sent you the link for this, or we've provided the link so you can go use it. You can figure out when International Space Station is visible again, when you can see it. Okay, great. Glad we've had a chance to show you that as well. All right, so now let's take some more of your questions before we close out for the evening. I'm going to stop my screen share right now. We'll come right back over to here, and we'll see if we have any other questions.
How long until we have the technology to conduct breakthrough star shots?
Say it one more time. Oh, how long before we have the capability to do breakthrough star shots? Oh my goodness, what an incredible program this is. So the question is, how long will it be before we have the technology and the capability to do Project Breakthrough star shots? Oh my gosh, what a great thing this is. So Project Breakthrough is a project that has been funded by a Russian oil billionaire. Stephen Hawking was part of this program, and a few other very, very wealthy people who are planning a project in which they can send tiny, tiny spacecraft from Earth all the way out to the next closest star to us, Proxima Centauri, where we think there is an Earth-like planet. And the idea here is that rather than sending a big spacecraft that's going to take a lot of energy and a lot of materials and all sorts of things like that to send it out there, the better idea is to send little tiny spacecraft, much smaller mass. And how would they, what kind of propulsion system would they use? Well, they would use light sails driven by lasers shot from Earth. So here's what would happen. These little tiny spacecraft would be sent up into space first, and then a laser beam would streak out from Earth and strike their sails, their very, very thin material sails, aluminized material sails, that would capture the photons from the laser beam, and the impulse of the laser beam striking the sail would push these tiny little spacecraft along. And the idea is that we could do this with lasers, and because the mass is so small, we could get spacecraft there in a quarter of the time it would take using any other method. So we could possibly be able to determine whether there was any intelligent life out, at that distance. By the way, it's 4 light years away, 26 trillion miles, 4 light years away. The idea is that we would be able to get an answer back in a very, very, very short period of time. So that's the idea behind the breakthrough Project Starshot. Just remembering all the details off the top of my head here, that's close to that. You can look this up online too and learn all about this particular project. It's really interesting what the possibilities are for this. So we'll take one last question.
Why do stars appear to twinkle?
Oh, this is a lovely question. Why do stars appear to twinkle? It's all because of the Earth's atmosphere. Starlight coming from a long way away comes down into the Earth's atmosphere, where different temperature layers in the atmosphere cause the light waves coming, the light beams coming from the star to bend around, and that causes the twinkle that we see. That twinkle, by the way, has a special name. You can actually look up the name of that twinkle, and you can find out what that term is. It's a very interesting and specific term for that. I'll let you look that up for homework. I know what it is. It's a big long word, starts with an S, ends with an N, and we'll check up with you next week to see if you remember what it is. Okay, don't forget, lots of stuff happening out there in the sky that you can see. If you want to learn how to do this, it's really very, very easy. You can use the programs that we've shown this evening, like Stellarium, to learn one constellation a night and then look for an adjacent constellation the next clear night you're out. Don't forget to look for the planets. Venus is going to disappear pretty soon over in the west. We won't have any planets in the evening sky again until July. If you're up early in the morning, don't forget to look over in the southeastern portion of the sky and look for Jupiter and Saturn. You can also look for Mars as well. And next Wednesday, May 27th, 4:33 p.m. in the afternoon, you'll be able to see the SpaceX NASA Demo 2 mission, sending 2 astronauts up to International Space Station on a brand new rocket in a brand new capsule. Don't miss that historic event. We'll talk about it next week. So, if there's anything that the COVID-19 pandemic has taught us, it's this. It is that science really matters. Don't forget that. Keep that in mind. Even while the Franklin Institute is closed, we're still finding new ways to continue our ever-important mission of sharing science and technology education, like this program you're watching now. By the way, thanks for joining us tonight. We hope you've had a good time. Come back and visit us again next week. If you're able, we would really be grateful if you'd consider donating to the Franklin Institute today or any other day. We'd really appreciate your support. It means so much to us. You can visit our website, fi.edu. You can click on the link in that post to leave us a gift. We would really appreciate that. It'll help us a lot. And as always, we thank you for your support. Thanks again for joining us tonight. Take a few minutes each day just to catch up to the night sky. Remember, it's your universe. Get out and explore it. Thanks a lot, folks. Have a great week. I'm Derrick Pitts, Chief Astronomer at the Franklin Institute Science Museum. You can catch me on Twitter @CoolAstronomer, and you can also send me email, of course, dpitts@fi.edu. Thanks a lot for joining us. Have a great week. Enjoy the night sky. See you later.
She does good.